We don't have an immense amount of time. Okay, does that look like a line segment?
Yes.
Does that look like a ray, part of a line?
Yes.
Okay, so the equations for these should look like a line. So this is a horizontal line. A horizontal line is always y equals. Well, what is the y value on that line? 2. So my first piece of this piecewise function is y equals 2, or f of x equals 2. Okay? Now I have to talk about where does this start and where does it stop. Those are the x values. What is the least x value on this graph?
-3.
-3. What is the greatest x value on that segment?
0.
0. So this goes from -3 to 0. That's interval notation. If you don't like it, write inequality. It goes from -3 to 0. You can do interval or inequality. These two things mean the same thing. Okay, now let's look at our next piece. This is also a line, but it's diagonal, so it better fit into y equals mx plus b. And it does. What is the slope? Up 1 over 2, up 1 over 2, up 1 over 2. The slope is 1/2. So it's 1/2 x plus the y-intercept is -2. What is the least x value on this?
0.
0. And it goes forever right. Infinity. So that's the interval. If we wrote this as an inequality, it would be all the x values that are greater than or equal to 0. You can do either one, or you can do either one, or. Okay, the next one also has two pieces. It almost looks like it's a reflection, but it's not quite. If we look at the slope of this part, it's up 2 over 1, up 2 over 1, and whereas this one's down 1 over 1, so it's not quite an absolute value function. That's what we'll be looking at tomorrow, though. Okay, so this slope was up 2 over 1, so that's 2x. Plus, what's the y-intercept? I don't see it. But do you see if I extended it, it would certainly be at 3. If we went up 2 over 1 again, we would see the y-intercept is at 3. We need that for the equation of the line. Even though this point isn't part of it, now we need to restrict the x values. So this goes forever left, -infinity. To what is the x value here? -1. Now because both of these share this dot, they share that point, we can either include the -1 here or on the next piece of the function, but not on both. And I included it here. You can either include it here or there, but not in both. Now if we wrote this as an inequality, it would be x values less than or equal to -1. Okay, now the next one, you already told me it has a slope of down 1 over 1, down 1 over 1, down 1 over 1 is -1, so it's -x. And the y-intercept is 0, so that's all we need is -x. And it is going to go from that -1 to positive infinity. So you could write x values that are greater than -1. And like I said again, we could swap the bracket and the parenthesis. We could swap the equal to and the no equal to. It just has to belong on one or the other. Okay, we're going to skip to the last one and we'll come back to this one. But the last one has this one, and this one. Do you see the 3 distinct pieces in this piecewise function? Okay, what does the first piece, the one that's most left, look like to you?
Square root.
This kind of looks like a square root, except
Exponential.
a square root would go this way.
It's also a parabola.
It's a parabola that opens down. And if we look at it, are my moves perfect? Over 1, down 1, over 2, down 4? Yes, the moves are perfect. So because it opens down, it's negative. It's going to be x minus the x value at the vertex, which they actually gave us, is -2, 1. So it's x plus 2 plus 1. But it's not the entire quadratic. It's not the whole parabola. It's only for x values that are less than or equal to 2. Or we could, thank you, -2. Or we could write it negative infinity to -2. Either way. Does that make sense?
Yeah.
All right. Okay, the next one is a line. It's just a plain old line. It's y equals what? 1. Okay, what's the interval? It goes from, what is this x value? -2 to +1. So if I wrote it as an interval, it would be -2 to +1. Now I chose to not include here because I included it with the first one. So if I were to write that as an inequality, it would go from -2 to +1. Okay, and the next one is the square roots. It sure is. And we can tell because 1, 1, 4, 2 by the moves. The square root of 1 is 1. The square root of 4 is 2. So this is a square root function that's been shifted over 1 and up 1. So it's going to be x plus 1 plus 1. No, x minus 1, excuse me. X minus 1, I'm sorry. Because it's +1, 1.
And you know square root because it's just like this?
Yeah, yeah. And we can check out the moves. And so this would be for x values that are greater than or equal to 1. Or we could say from 1 to infinity. Okay, make sense?
Yeah.
All right. Let's see what you can do on the homework tonight.
We have more lessons that take only 5 minutes.